Hello everyone. So today in this video we're going to discuss a very interesting topic from Leetcode. The problem name is, as you can see, finding out whether the given binary tree is a symmetric binary tree or not. Now what I mean by symmetric is, as you can see, if you draw out a straight line, a horizontal line dividing this tree into two halves, then the left half and the right half should be same. They should be like a mirror image to each other, as you can see. So we'll go through some example, the same example. So let's assume that I have a tree with the first node 1. If the left and right node may be 2 also. If I draw out a straight line or horizontal line, then if this node is 3, okay, then this node should also be 3. And this is how, if this node is 4, this node should also be 4. And that's how we can say that this tree should be symmetrical. Now how we can check this out? Now what you can simply see by observation till now here is that for these two nodes, the left child of this particular node should be equal to the right child of this node. And same, the right child for this node should be equal to the left child of this node. So I hope you understand or you are getting some sort of intuition. So what we are actually used to write a recursive function, because in most of the binary tree problems, what we can see here is that recursion is used very widely. So if you are comfortable in recursion, then you can easily solve out these problems out. So now in each recursive problems, there are 3 steps. The first one is the base condition. The second one is somewhat a checking condition. And the third one is recursively calling this function again. Recursive callback. So we'll recursively call this function again. So these are the 3 points you have to keep in mind while writing any of the recursive function. Okay, so now what we're going to see here is, now first find out what is the base condition for this whole problem. The base condition is 1, the code should terminate out. The code will terminate out at the point when the left and the right child, when the left and the right pointer should be null, or when we are at the child node. So this is somewhat a child node or the leaf node, you can say. At these points, what we can observe here is that the program should terminate because we cannot go more further down. So the program will terminate when we encountered a left and the right child of any node is equal to null. So that's the base condition. Okay, so if we hit true, so let's assume that I have only one node like this, and both of them, the right and the left child, are null, then obviously this is true. This is a symmetrical tree. So for this condition, the answer should be true. The answer can be false when, if I have a node and the left node exists, if it is 2, and the right node do not exist, it is null. Or else the same happen that the left node is not existing but the right node exists. In that case also it is not symmetrical. And also let's assume that I have one node, this is 2, but this value is equal to 3. Then this is also not symmetrical because left half is having the value 2 and the right half is having the value 3. So I hope you get the point. These are the 3 conditions in which we are telling that this is not a symmetrical tree. Okay, and the recursive callback function here is, we have to somehow call this function again, following the condition that in the next call we are actually writing out a check function. The check function will take 2 pointers, the left and the right. The left child, these are tree pointers, tree node pointers. Okay, so as you can see in the example, these are tree node pointers. So that's what we're gonna see here is, these both are tree node pointers. And then at each step, we'll call this recursive function or this check function again, in which in the next iteration, we will check that the left pointer of the current node and the left of the left pointer and the right of this should be same, and the right of this left pointer and the left of this right pointer should be same. Both of these conditions should match, and in the end, if they all matches this whole condition, then the answer is true that this is a symmetrical tree. Else the answer is that this is not a symmetrical tree. So that's the whole logic for this problem. You will understand more with the code part now. So as you can see in the code part, we have the left and the right pointer. The base condition, as you can see, is here, in which the left and the right pointer both becomes null. Then the answer is true, because in that case, as I've seen, that if the left and the right pointer both becomes null, then the answer is true. We are calling this symmetrical function, in which we are sending out and calling this check function for the root left pointer and the root right pointer. Okay, then what we're gonna see here is that if the base condition is done, now the checking condition is if the left pointer is null or the right pointer is null. Okay, if both of them are null, then the answer is true. If only one of them is null, then it is bad. If any one of them is null and the other is not null, and also the other case can be that the values of the left and the right pointer do not match out. If they do not match out, then the answer is false. And the recursive callback function part is we have to again call this function again in two cases. The first case can be call this recursive function again for left of left point and the right of the right pointer, and checking the left of the right pointer and the right of the left pointer. Okay, we'll call this function again and we'll do an AND operation, which means that both of these recursive callback function should return out true. Then only the answer should be true. So this AND means that both, it's an AND operator, bitwise AND operator, in which both the left and the right should be true. Then only it will give true. And in the end, if this whole recursive function is returning out true, then the answer is that this is a symmetrical tree, else this is not a symmetrical tree. I hope you understand the logic and the code part for this problem. If you still have any doubts, you can mention down.